First chapter of class 10th is chemical reactions and equations. Chemical reaction and equations. We have to study about the chemical reactions and equations in this chapter. First topic is physical and chemical changes. Physical and chemical changes. A phenomenon in which no new substances is formed is a physical change. When no new substance is forming, that change is a physical change. Example, melting of ice. Melting of ice. It is a physical change as it involves only the change in the physical state of a water from solid to liquid. When ice will melt, it will change from just solid to liquid state. No new substance is forming, hence melting of ice is a physical change. Another example is dissolution of sugar in water. Dissolution of sugar in water. That is dissolving sugar in water. When sugar is dissolved in water, sugar will remain as it is and water also remains as it is. It's just the sugar goes into the empty spaces between the water molecules. So new substance is not formed here. Hence, it is a physical change. Now, next is chemical changes. The changes in which new substances are formed. Changes in which new substances are formed, which will have properties entirely different from the substances from which they are forming. These are called chemical changes. For example, burning of a paper. Burning of a paper is a chemical change as new substance is forming here. Which new substance forms when we burn a paper? Paper for burning requires oxygen. Paper burns in presence of oxygen. And after burning of paper, smoke and ash will form. So these two substances are entirely different from paper. Their properties are different from paper. Since new substances are forming, hence burning of paper is a chemical change. So this is what is a physical change and what is a chemical change. Now one question is here, is burning of candle a physical or a chemical change? Is this a physical change or a chemical change? Let's understand this step by step. Observations when we ignite a candle, and then type of change. First, burning of wick of candle. First, the wick of candle burns. So when wick of candle is burning, it is a chemical change. Actually, burning of anything will come under a chemical change. With burning, always entirely new substances they will form. Next, after burning of wick of candle, melting of solid wax takes place to form liquid wax. So now only melting of wax is taking place. Hence it is a physical change because only physical state of wax is changing here. Now after melting of wax, third step is now evaporation of liquid wax to wax vapors will take place. Now again a physical state only is changing. Liquid wax is just changing to the wax vapors to gaseous state. Hence this step is actually a physical change. Now next step is the wax vapors which are formed. Burning of these wax vapors will take place. Like I told you, burning is always a chemical change because entirely new substances they form. So this step is a chemical change. So what we conclude from this entire thing, that burning of candle has both physical and chemical changes involved in it. After knowing what is a physical and a chemical change, move on to our next topic, chemical reactions. Chemical reactions. What is a chemical reaction? A process in which one or more substances are converted into different substances having different properties is known as a chemical reaction. So can we say chemical change is a chemical reaction? Because here entirely new substances with entirely different properties they will form. And repeating the definition, chemical reaction, it is a process in which one or more substances are converted into different substances having different properties is known as a chemical reaction. In a chemical reaction, the substances are changing to new type of substances. Substances are changed to new type of substances. In a chemical reaction, chemical change occurs, which involves the rearrangement of atoms. Like for example, these are the two substances I'm taking, A and B. And after a chemical process, they are forming AB. So how this AB will form? The bonds in these atoms here, they are breaking. So when these will break, they are free now. So when they are free, they are rearranging themselves to form an entirely new substance. So in a chemical reaction, chemical change occurs which involves the rearrangement of atoms. It involves the breaking of old bonds between atoms, taking part in a reaction and formation of new chemical bonds to form a new substance. The substances that take part in a chemical reaction, these substances are taking part in a chemical reaction. These are called reactants. Substances which take part in a chemical reaction are called reactants, and the new substances formed are known as products. So in a chemical reaction, there are reactants and there are products. Our next topic, chemical equations. What are chemical equations? Writing of chemical reaction using symbols and formula of substances involved is called a chemical equation. Writing chemical reaction using symbols and formula of substances involved is called a chemical equation. Now, rules for writing a chemical equation. How chemical equation can be written? First rule is, substances taking part in a chemical reaction, like I told you, are called reactants. These are written on the left hand side in chemical equation. And the substances formed after a chemical reaction, which are called products, are written on the right hand side in a chemical equation. Third rule is, the sign of arrow. The sign of arrow is put in between the reactants and the products, pointing towards the right hand side. And plus sign is used between the reactants and the products. Example, magnesium burns in air. So magnesium is a reactant. Burns in air. Burns in air means it burns with oxygen present in air. For burning, oxygen is required. And after burning, it forms a new substance, magnesium oxide. Which new substance is formed here? Magnesium oxide. These two are reactants, and this new substance formed is a product. Reactants are written on the left hand side, products on the right hand side. Between the reactants and the products, there is a sign of arrow that is pointing towards the right side. Between the reactants, plus sign, and between products, if more than one product is there, between the products also we use a plus sign. The above word equation, this is written in words, magnesium plus oxygen forming magnesium oxide. If this chemical reaction we write using the symbols and the formula of these substances involved, then this chemical reaction is known as chemical equation. For example, magnesium symbol is Mg and oxygen is O2. Its formula is O2. And magnesium oxide formula is MgO. So when we write this chemical reaction using symbols and formula of the substances involved, then this is known as chemical equation. So this is a chemical equation, while this is a chemical reaction. Written in words is chemical reaction. Written using symbols and formula is known as chemical equation. Now you have to note one thing here. Like I have used this 2 and 2 here. This you will understand afterwards in the chapter. A chemical equation must be a balanced chemical equation. That is, number of atoms of each element on left hand side and right hand side must be equal. So this topic, how to balance The chemical equations we will do in the next lecture. Next topic, chemical reaction investigation in science laboratory. First investigation. Burning of magnesium ribbon in air. Magnesium is a silvery white metal in the form of ribbon in the lab. This metal is of silvery white color and in the lab it is available in the form of a ribbon. Magnesium has a layer of magnesium carbonate on it. So before burning this magnesium ribbon, we have to remove this magnesium carbonate layer, and for that we use a sandpaper. Using the sandpaper, we remove that magnesium carbonate layer from magnesium because we have to burn magnesium and not magnesium carbonate. So what we'll do now, after rubbing the magnesium ribbon with sandpaper, hold it with a pair of tongs. So you have to hold it using a tong. This is suppose a magnesium ribbon. Hold it from one end and burn this other end using a burner. Now collect the ash formed. The ash will form when we'll burn this magnesium ribbon. This you collect on watch glass or in a china dish. This we have collected either in a watch glass or in a china dish. What we will observe? Observation. When magnesium ribbon is burnt in air, when this is burnt in air, it burns with a white dazzling light and a white colored magnesium oxide is formed as ash. So this ash that is formed after burning of magnesium ribbon is actually a new substance, magnesium oxide. So what happens here is magnesium burns in air and forms an entirely new substance, magnesium oxide. Entirely new substance, magnesium oxide is formed. This is silvery white color metal and this is a white color powder formed as ash. So what we conclude from this investigation, what we'll conclude when we burn magnesium ribbon, we conclude that this is a chemical reaction. It is a chemical reaction. Why? Because entirely new substance, magnesium oxide with different properties is formed from magnesium and the oxygen reactants. So hence it is a chemical reaction. Investigation 2. Second investigation. In this, we'll mix lead nitrate and potassium iodide. mixing of lead nitrate and potassium iodide. We'll make a solution of lead nitrate and potassium iodide by dissolving these salts in water. And both the solutions formed of lead nitrate and potassium iodide are colorless. So we take 20 drops of lead nitrate solution in one test tube and 20 drops of potassium iodide solution in another test tube. So in two test tubes, different test tubes, we have taken lead nitrate in one and potassium iodide in the second test tube. Now pour potassium iodide solution into the test tube containing lead nitrate solution. What we will observe? On mixing, suppose this test tube has lead nitrate. There's a colorless solution in this. And second test tube has potassium iodide solution. This is also colorless. Now add the potassium iodide into the lead nitrate solution. On adding, what we'll see, there's a formation of yellow color precipitates. Precipitates means some solid particles will form in the colorless solution here. Yellow color precipitates we will see here in the test tube. Precipitate means some solid particles. Precipitate can be written using PPT symbol. So what happens here is potassium iodide aqueous. Aqueous means its solution in water. Lead nitrate aqueous, its solution. These two are the reactants. On combining the two, we get PbI2, that is lead iodide. The yellow precipitate formed here are of lead iodide. And the solution here is of potassium nitrate. Solution is of potassium nitrate. This is potassium iodide formula. This is lead nitrate. These two are reactants. On combining the two, we get lead iodide in the form of yellow precipitates. This arrow here shows that these particles are settling down. See here, these particles are heavy as compared to the solution, so they will settle down. This arrow shows that they are going down. And this is potassium nitrate formula. So what we conclude from this observation? That this is a chemical reaction. Why this is a chemical reaction? In this reaction, lead iodide yellow precipitate formed have entirely different properties from the reactants, that is potassium iodide and lead nitrate. Because this has entirely different properties from these substances, so this is a chemical reaction. This is a conclusion. Now investigation 3. reaction of zinc granules with dilute acids. Zinc is in the form of granules. Granules means big pieces. Big pieces like this. Zinc is available in the lab in the form of granules which are of grey color. And dilute hydrochloric acid. Its formula is HCl. And dilute sulfuric acid. Its formula is H2SO4. These are colorless. These acids are colorless. Now what we have to do? Take few pieces of zinc granules. These few pieces of zinc granules we have to take in a test tube. This we have to take in a test tube. And to this we have to add dilute hydrochloric acid or dilute sulfuric acid and observe the changes. Observation. What we will observe when we add dilute acid to the zinc granules. When dilute HCl or dilute sulfuric acid is added to the test tube containing zinc granules, a colorless gas evolves. A colorless gas will evolve here. This gas burns with a pop sound, which indicates that the evolved gas is hydrogen, because hydrogen always burns with a pop sound. Zinc is in a solid state, so S is for showing that this is in a solid state. To zinc we add hydrochloric acid, or to zinc we add sulfuric acid solution. So aqueous, AQ is used to show it is a solution in water. What happens when we add hydrochloric acid to the zinc granules? Zinc chloride will form with an evolution of hydrogen gas. And if we add dilute sulfuric acid to the zinc granules, then zinc sulfate will form with an evolution of hydrogen gas. This is zinc chloride formula, and this is zinc sulfate formula. What is the conclusion? That this is also a chemical reaction. The products formed in these reactions have entirely different properties from the reactants. So these are also called chemical reaction. These are also called chemical reactions. Now after this we move on to the next topic. Characteristics of a chemical reaction. What are the characteristics of a chemical reaction? How we will come to know that this process which is taking place is a chemical process, is a chemical reaction. How it is different from a physical change. So first characteristic is, if there is evolution of gas, then it is a chemical reaction. If there is evolution of gas, then this is a chemical reaction. Example, just now we have done zinc when reacts with sulfuric acid or with hydrochloric acid, there is evolution of hydrogen gas. So if the gas evolves in any process, that is a chemical process, that is, this is a chemical reaction. In this reaction, which gas evolves here? Hydrogen. Second example, if we take sodium carbonate, it is in solid state, and to this if we add hydrochloric acid, these will react to form sodium chloride solution, water plus carbon dioxide gas will evolve here. Which gas will evolve here? Carbon dioxide gas will evolve here. This is the formula for sodium carbonate. This we know is hydrochloric acid. This is the formula of sodium chloride. And in this process, which gas evolves? Carbon dioxide. So if there is evolution of gas in a process, that shows that this is a chemical reaction. Second characteristic of a chemical reaction, formation of precipitate. Example, potassium iodide and lead nitrate that we have just done. Yellow PPT of lead iodide forms here. So, formation of yellow color precipitates here. We had taken the colorless solutions, but we are getting the precipitates here. So, formation of precipitates in a process shows that this is a chemical reaction. Second example, if we take a barium chloride solution and to this we add sulfuric acid, this formation of white precipitates of barium sulfate along with the formation of HCl. Sulfate combines with this barium, so barium sulfate, and this combines with the Cl and this formation of hydrochloric acid. This is the formula of barium chloride and this is barium sulfate. So white precipitates they form here, yellow precipitates they form here. If precipitates they form, it shows that this is a chemical reaction. Third characteristic is change in color. Example is you take potassium permanganate. Potassium permanganate solution. This is of purple color. And to this if we add oxalic acid. This is colorless, this is purple in color. When we add oxalic acid to potassium permanganate, its purple color disappears. Purple color disappears. It becomes colorless. So when change in color is there, that shows that this is a chemical reaction. Fourth characteristic is change in temperature. If temperature changes, there is increase or decrease in temperature. Example, if we take calcium carbonate, that is chalk, and add water to this formation of calcium hydroxide plus heat. So if you take calcium carbonate it has to be calcium oxide here, not calcium carbonate, calcium oxide, CaO, calcium oxide. Calcium oxide, if we take in a test tube or in a beaker and add water to this and touch the beaker now, you will feel that it is very hot. Why? Because when the two are reacting, heat evolves, heat comes out from it, and because of which the beaker will be hot. So temperature increases as heat is liberated. So there's change in temperature here. Another example, if we take barium hydroxide solution and to this we add ammonium chloride solution. The two solutions, when we mix, formation of barium chloride takes place, ammonia gas will evolve, and water will form. In this case, if we'll touch the beaker, when you mix the two solutions and touch the beaker, you'll find that the beaker is cold because heat is absorbed here. That is, temperature decreases as heat is absorbed. So when there's change in temperature, then it shows that this is a chemical reaction. Last characteristic. Change in state. State means from solid to liquid, liquid to gas, or vice versa. Example, if we take hydrogen gas and oxygen gas and mix the two, this formation of water, we had taken gaseous substances but liquid substances forming here. So physical state is changing here. That shows that this is a chemical reaction. A new substance is forming, but its physical state is different from these substances, from these reactants. So change in state is there, hence it is a chemical reaction.